guys, it's time for another one of those mini lectures for physical geography. For this mini lecture, we're going to learn those 7 important lines of latitude, those 7 parallels. Yes, we're going to memorize them, the name and the degree, but we're also going to understand the significance of each line. We're going to draw these 7 parallels out together. So go print out that 7 parallel PDF. Get some pencils or pens, maybe a ruler, and we'll get started on this. Let me apologize in advance. Your hand drawings are always better than mine. You'll quickly get used to my poor writing and drawing skills. So on this first one, we already know it, right? Go ahead and write in the equator, and it represents 0 degrees latitude. Now, what is the significance of the equator? We love that word, right? Equator, equal. It is drawn equal distance between the North Pole and the South Pole. We will quickly notice that these 7 important lines of latitude, they have a direct correlation with the sun and sunlight. Well, at the equator, we have equal amounts of daylight and darkness. What does that mean? Well, at the equator, you get 12 hours of daylight, 12 hours of darkness every single day of the year. The next 2 lines of latitude are actually more of a polka dot. You know of these. They are found at 90 degrees north and 90 degrees south. We call the one in the northern hemisphere the North Pole, the one in the southern hemisphere the South Pole. When I say it's a polka dot, I mean you and I could literally stand on the North Pole and our entire body would take up that position. When we write degrees, how important is it to include the N regarding the north or the S regarding the south? Should we use it sometimes when we're in the mood, or is it super duper mega important and you must include it? Yeah, it's super duper mega important. You have to include the N for north or the S for south. How else would I know which pole you're referring to? You have to include the N or the S on all the degrees with regard to latitude. Remember, the 7 important parallels, they have a relationship to the sun and daylight and darkness. At the North and South Pole, each gets 6 months of complete daylight and 6 months of complete darkness. Do you remember the axis tilt of Earth in relationship to the sun in degrees? It's 23.5, right? Well, then it's no surprise that these next 2 lines are also 23.5 degrees. We have one in the northern hemisphere, the Tropic of Cancer, that's at 23.5 degrees north. Don't get it mixed up with its counterpart in the southern hemisphere. It is called the Tropic of Capricorn at 23.5 degrees south. What is the significance of these 2 lines? Well, the Tropic of Cancer marks the northernmost point to ever receive the direct rays of the sun, and the Tropic of Capricorn is the southernmost point to ever get the direct rays of the sun. Direct rays are those vertical rays of the sun. When the sun is directly overhead, when it's on a 90-degree angle with Earth's surface, when it's perpendicular to Earth's surface, there are a number of ways to describe this, but this diagram shows that, for example, the equator is receiving direct 90-degree rays. The way they hit the Earth is on a 90-degree angle in comparisons to latitudes that are more north. So the Tropic of Cancer is the northernmost latitude that will ever receive those direct rays of the sun. And the Tropic of Capricorn is the southernmost latitude to ever get those direct rays of the sun. Even if we were standing just north of the Tropic of Cancer, we would not receive the direct rays of the sun. If Cerritos College is at 33 degrees north latitude, when do we get the direct rays of the sun? Think about it. When does Cerritos College get the direct rays of the sun? Nunca. Never. It doesn't matter if it's 12 noon. It doesn't matter if it's summer solstice. It doesn't matter if it's summer. We never get the direct rays of the sun. We're at 33 degrees north. It is impossible. We made it, folks. We're about to wrap up our last two important lines of latitude. But this time, take that 23.5 degrees, that axis tilt, and subtract it from 90. What do you get? 66.5 degrees. So we have the Arctic Circle in the northern hemisphere at 66.5 degrees north, and the Antarctic Circle at 66.5 degrees south. What is the significance of these two lines of latitude? Within these areas, from the Arctic Circle up to the North Pole, from the Antarctic Circle down to the South Pole, you can get 24 hours of complete daylight and 24 hours of complete darkness at least once a year. If we were just south of the Arctic Circle, would we get 24 hours of total daylight or darkness? No. You have to be at those circles or up to the poles to get 24 hours of daylight or darkness. You might get 23 hours and change of daylight or darkness, but it will not be 24 hours of daylight or darkness. Within these areas, there's a range with regard to how long the daylight or darkness lasts. For example, if you're at the Arctic Circle, you'll get a day. If you're at the poles, you're going to get 6 whole months. We can describe the Arctic Circle as the southernmost point in the northern hemisphere to ever get 24 hours of complete daylight or darkness. We can describe the Antarctic Circle as the northernmost point in the southern hemisphere to ever get 24 hours of complete daylight or darkness. We've learned the 7 important parallels. We know their names, we know their degrees, and we're going to make sure that we feel really good about the significance of these because it's important to understand these to fully understand the revolution of Earth around the sun and its relationship to seasons. We are also discovering the relationship between the sun's rays and these lines of latitude. One way to describe this is that at the equator, you get equal amounts of daylight and darkness, and as you get further away from the equator, we have more extremes with regard to daylight and darkness. What does that mean? It means that at the equator, you're going to have equal amounts of daylight and darkness, 12 hours of daylight, 12 hours of darkness every day of the year. But as you go further away from the equator, up toward the poles, you will have more extreme amounts of daylight and darkness. What would be the most extreme amount of daylight and darkness? Like you find at the poles, 6 months of daylight and 6 months of darkness. To understand this, let's use Cerritos as a baseline for us, since we're all pretty familiar with Cerritos. Remember, we are at 33 degrees north latitude. And when you think about our daylight and darkness over the course of a year, and if you think about when it gets dark over the course of the year, it gets dark earliest in December. And let's say it's about 5 o'clock. Let's just all agree it gets dark about 5. And what time does it get dark in the summer on our longest day of the year? Let's just agree it's about 8:30 p.m. So remember, places that are at a more northern latitude, they're going to have more extremes with regard to daylight and darkness. Now, I've never been north of the Arctic Circle or south of the Antarctic Circle, so I've never experienced 24 hours of complete daylight or darkness. However, I have been to Stockholm, Sweden. It's at 59 degrees north latitude, and again, it's not within the Arctic Circle, so you're not going to have 24 hours of daylight or darkness there. I was in Stockholm, Sweden in the middle of summer, and there was still a little bit of sunlight at midnight. You see how there's still some sun off into the distance there? That could be midnight in Stockholm. Now, I'm not a morning girl, but rumor is that the sun was coming back up around 4 a.m. What does that mean? In the middle of summer, Stockholm, Sweden only gets 4 hours of darkness. Do you see how that is much more extreme than our experience at the same time in the summer? So what's it like in Stockholm, Sweden in the winter? Well, my friend Annika, who grew up there, she said that the sun would start to come up around 10 a.m. 10 a.m., what was that, like recess or nutrition time for us? And the sun would be back down by 2 p.m. So in the winter, it has more extreme amounts of darkness with only 4 hours of daylight in the winter. Let's look at one more example. I spent a month in Ecuador. By the way, it was a great trip. I went to the Galapagos, I went to the Western Amazon and lived with an indigenous family. But the bulk of my time was in Quito, the big city. And I'm traveling by myself, so I want to make sure that I'm making good decisions. Now, I'm staying with a family there, and if I'm in Ecuador, use the word here to help you out, what time do I want to make sure that I am back in the family's home to make sure that I'm not out after dark? Think about it. Make your guess. If you said 6 p.m., you are correct. If I want to get home before it gets dark, I have to be home by 6 p.m. And by the way, the sun rises every single day at 6. Why? Because we're at the equator in Ecuador, and at the equator, you get 12 hours of daylight, 12 hours of darkness every single day of the year. Okay, let's go ahead and wrap this one up. We've learned the 7 important parallels. We understand the relationship to sun. But for you guys, make sure that you feel really comfortable with all of this because it will be important for our understanding of the seasons and revolution of Earth around the sun.